Example 6 figure 2 number 12 shows an electric circuit. Here is the battery and a fixed resistor, lamp, and an ammeter. The lamp lights, but the ammeter needle moves in the wrong way. What changes should be made so that the ammeter works correctly? As you can see here, the ammeter, the positive part of the ammeter is connected to the negative part of the battery, and this is wrong. They should be having the same polarity, so we shall connect the ammeter, the negative part of the ammeter, to this wire, and the positive part should be connected to this wire. So how we could say this? Simply, we shall say reverse the connection between the ammeter and the battery. What does the ammeter measure? As we know, that we have a voltmeter that measures the volts or the potential difference or the EMF, and for the ammeter it measures the current or the amps in a circuit. In the symbol, we draw a circuit diagram of the circuit using the correct circuit symbols. Let's move up and let's draw the circuit here next to it. Let's start with our battery. As we said before, we will start with the battery, positive and a negative. Here is the positive, here is the negative. And then after the positive, we could see that we are connecting it to a fixed resistor. So here is the symbol for the fixed resistor. And then a lamp. Here is the symbol of the lamp. So the other part of the resistor is connected to a lamp. The other part of the lamp is connected to an ammeter. So we could draw it like this, and each side. And then the other part of the ammeter is connected to a battery, and here is the battery. That's the circuit and how we could do it all connected in series. And then moving on to the next one, name the instrument that could be used, that would be needed to measure the potential difference across the 15 ohm resistor. Across the 15 ohm resistor, in order to measure the potential difference, we just said that we need to have something called a voltmeter. Using the correct symbol, add the instrument in the circuit diagram in the position to measure the potential difference across the 15 ohm resistor. Where is the 15 ohm resistor? Here is the 15 ohm resistor. So in order to add the voltmeter to measure the potential difference across it, so shall connect the voltmeter like this across the 15 ohm resistor. Here is the 15 ohm resistor. The potential difference across the 15 ohm resistor is 6 volt. So now this is a very straightforward question, the current in the circuit. So what you have here is that there is Ohm's law, I and an R. So he needs the current. Current is equal to V over R. So it will be a 6 over 15. So at last it will be an 0.4 ampere. Then moving on, without any further calculation, what would be the current for the lamp? The current for the lamp, as we said before, that inside a circuit or a series circuit, in any part of the circuit, the current will be the same. So for example, the current here should be the same as here, should be the same as here, should be same here, anywhere in the circuit. So here we got the current inside the circuit was 0.4. So without any further calculation, the value of the current in the lamp will be 0.4 as well. So here is the right answer. And then moving on to the next part. Another 15 ohm resistor is connected in parallel with the 15 ohm resistor that is already in the circuit. What's the combined resistor of the two 15 ohm in parallel? Okay, in order to get, first of all, here is the drawing for a parallel connection. We drew it in black. So here is the 15 ohm resistor, and then the lamp, and then the ammeter. Okay, in here. So in order to have a parallel connection, here is the 15 ohm resistor, and they are sharing the same starting point and the same ending point. Here is the 15 ohm, and here is the other one connected in parallel 15 ohms. Okay, in order to get the combined resistance between them, so as if both resistors will be a one resistor, we know before that R total for the parallel connections is equal to product over sum, which means it will be a 15 times 15 over 15 plus 15. So final answer will be 7.5. So as you can see, the both resistance when they were in parallel, the total resistance of the circuit now decreased, became 7.5. Okay, and then what state what effect we could have on by adding an extra resistor as on the current of the lamp. We said that because we connected two resistors in parallel, it means that we decreased the resistance. As you can see here, when they were connected in parallel, the total resistance was 7.5. Here, when it's connected in series alone, it was a 15. So it means that when it's connected in parallel, so the resistance decreased from 15, it became 7.5. So it means that when the resistance decreased, so the current will increase. So here at this point, we could say that it will increase. Thank you so much.